Hey everyone, welcome to writing expressions of complex numbers. We're going to write these in polar form, okay? So we also call this trig form. So we've got a couple of examples to show you, but the goal today is if I give you a complex number, okay, can I write it in polar form? And that's what we're going to show you today. So let's go ahead and get started. A couple things you want to be able to remember to write complex numbers in polar form. You need the following information. A equals r cosine of theta, b is equal to r times sine of theta, okay? R, often called the modulus, which is just the distance, is the absolute value of z, which is just the square root of a squared plus b squared. Okay, we also have to think about a plus bi. Remember, here's the complex plane here, so we go a over and b units up. You can also consider that a being your x value, b being your y value. So here's the polar form right here. Okay, it's just going to equal to r times the quantity cosine theta plus I times sine theta. So the things that we need to make sure we have are r and theta for this. To find theta, most of the time we're going to use right triangle trig. Okay, and just a side note here, so for the modulus r. So when I do these types of problems, okay, I like to do the following things. I identify my a and b. Sometimes I may need to expand in case what type of number or complex number I'm given. I like to find r, okay? Then I like to find theta. And this here will probably be the most tedious step, okay? And then the last part is you just fill in the formula. The z equals, okay, r cosine r times the quantity cosine theta plus I sine theta. So we're going to present three examples, not all in the same video because that will run a little bit long, but we're going to go ahead and convert each of these numbers into polar form. Okay, so we're going to start, okay, with 2 plus 2i. So I'm going to go ahead and rewrite this. So we're going to have 2 plus 2i. Okay, a is my real part, so I know that a is going to equal 2, and I know that b is going to equal 2. Okay, so that's fairly straightforward. So now I know that r is equal to the square root, the modulus there, of a squared plus b squared. In this you can ignore the sign because you're always squaring those two numbers, so just ignore whatever sign these are, okay, for r. So you're going to have the square root of 2 squared plus 2 squared. That is equal to the square root of 4 plus 4, which is 8, or 2 root 2 after simplifying. Okay, so now I have my a and b. There's my r value. Okay, and so if I look at where I am in the process here, I've done r. Okay, now I need to find my theta. Okay, so let's go ahead and draw this picture. Okay, so I'll go ahead over here, draw my picture. And I don't need much, I need just 1, 2, 3, 1, 2, 3. So 2 is here, 2 is here. We're going to make a point. Okay, so here's theta. Okay, so we have 2 and 2 here. Okay, so we're going to use the tangent of theta is equal to opposite over adjacent, which is 2 over 2, which is 1. So basically now you're asking what angle of theta gives me a tangent of 1? Well, that's where cosine and sine are equal. So this is actually 45 degrees or pi over 4. Okay, so now we have theta. Now we fill in the formula. Our formula, let's go ahead and rewrite this. Okay, z is equal to r times cosine of theta plus I sine of theta. Okay, there we go. Now we substitute. Here's r. 2 root 2 times the quantity cosine of, I use radians, pi over 4, plus I sine of pi over 4. And that is our complex number written as a polar equation or a polar expression. Okay, so we're in polar form. That's all you need to do. We do not need to simplify that out. So if we have any questions or comments on this first example, go ahead and type them below. We'll see you next time.